Hello, good morning viewers. Let me show you how you can find the trigonometric ratios of these three angles using different triangles. Alright, let me start with 30 and 60 simultaneously using an equilateral triangle. You know, an equilateral triangle has all its sides equal and all the interior angles equal. Okay, let me draw that. Remember that all these angles are equal to 60 degrees each. And all the sides are equal. So if this is x, this must be x, this must be x. And to the lowest term, their ratios will be 1 to 1 to 1. But remember that a right angle triangle is very essential when it comes to trigonometric ratios. So we are going to divide this triangle into two equal parts, forming a right angle triangle. So this is how I will divide it, like this, forming a right angle here. And it will be half-half. So I have just divided the triangle into two. Therefore, this angle will be 30 degrees. This will also be equal to 30 degrees. Well, what about the side lengths? This will be 1 over 2. This will be 1 over 2 because I have divided the 1 into 2. So now let me bring one of the triangle outside. So this is the triangle. Let me level it. This is 30 degrees. This is 90 degrees. And this is 60 degrees. This side length is 1 over 2. This remain 1. This is what we need to find. So let me call it x. Remember that Pythagoras rule stated that hypotenuse squared is equal to the opposite squared plus the adjacent squared. And hypotenuse is the longest side, which we have one here. Talking about this angle 60 degrees, this is said to be the opposite and this is the adjacent. So we have 1 squared equal to x squared plus 1 over 2 squared. 1 equal to x squared plus 1 over 4. If you make x squared the subject, you have x squared equal to 1 minus 1 over 4. X squared will be equal to 3 over 4. And to find x, you're going to take the square root of both sides. X equal to square root of 3 over 4, which is equal to root 3 divided by 2. Therefore, this side length x is equal to root 3 over 2. Okay, now let us go ahead and start finding the ratios. But you need these three formulas. They are very important. Let me write them for you. We have sine of an angle equal to opposite divided by hypotenuse. Cos of an angle can be obtained by taking adjacent divided by the hypotenuse. And finally, looking for the tangent of an angle is equal to opposite divided by the adjacent. Okay, so now let us start with 60 degrees. Sine 60 degrees equal to opposite divided by the hypotenuse. The opposite is root 3 over 2. So we have root 3 divided by 2 divided by the hypotenuse, which is 1. And 1 will not change it. This is equal to root 3 divided by 2. Then for cos of 60 degrees is equal to the adjacent divided by the hypotenuse. We have the adjacent of 60 degrees as 1 over 2 divided by the hypotenuse, which is 1. This is the same thing as 1 over 2. And lastly, for tangent of 60 degrees is equal to the opposite, which is root 3 divided by 2. divided by the adjacent, which is 1 over 2. And this is equal to just root 3. So now you can see that we have our three ratios, 1 here, 2 here, and the last one here. Okay, let us go on to 30 degrees. Sine 30 degrees is equal to the opposite all over hypotenuse. The opposite of 30 degrees you can see is 1 over 2, and the hypotenuse is 1. So this is 1 over 2 divided by 1, which is the same thing as 1 over 2. Cos of 30 degrees is the same thing as adjacent divided by hypotenuse. The adjacent is root 3 over 2 and hypotenuse is 1. So we have root 3 over 2 divided by 1, which is the same thing as root 3 divided by 2. And lastly, for tangent of 30 degrees, remember it is opposite divided by adjacent. This is opposite, this is adjacent. So we have 1 over 2 divided by root 3 over 2. 1 over 2 divided by root 3 over 2. And this is equal to 1 over root 3. But if you like, you can rationalize it. 1 over root 3. You can multiply the top and the bottom by root 3 over root 3. And this is equal to root 3 over 3. So this is equal to root 3 over 3. So this is all about 30 and 60. Let us move on to the last one, which is 45 degrees. We can obtain angle 45 degrees in an isosceles right angle triangle. Okay, this is an isosceles right angle triangle. This is 90 degrees. This is 45. This is also 45. Remember that the two opposite legs of an isosceles triangle are equal. So if this is x, this must be x. Their ratios will be 1 to 1. So this is 1 and this is 1. And this is the hypotenuse of this right angle triangle, which we need to find. To find that, remember that hypotenuse squared is equal to opposite squared plus adjacent squared. The hypotenuse squared, which we are looking for, remain hypotenuse squared. And both opposite and adjacent are 1, so we have 1 squared plus 1 squared. Hypotenuse squared is equal to 1 plus 1, which is equal to 2. Therefore, the hypotenuse that we are looking for is equal to square root of 2. So this is square root of 2. So let me start with sine ratio. Sine of 45 degrees, remember it is equal to opposite divided by hypotenuse. The opposite is 1 and the hypotenuse is root 2. If you rationalize the denominator, you will have root 2 divided by 2. Then for cos of 45 degrees, it will be equal to the adjacent divided by the hypotenuse. The adjacent is still 1 divided by the hypotenuse, which is root 2. Rationalize this, you have to get root 2 divided by 2. This implies that both sine and cos of 45 degrees are equal. Then the last one, which is tangent of 45 degrees, it is equal to opposite divided by adjacent. Both opposite and adjacent are equal to 1. We have 1 divided by 1, which is equal to 1. Therefore, tan of 45 degrees is equal to 1. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.